Hello everyone, I'm Sonali Pawar. This is our lecture of audio video engineering. The first unit is fundamentals of television. In the fundamentals of television, we have seen how the television system works. That is how whatever the process is done at transmitter side and at receiver side that we have seen. After that, we have seen different scanning principles. We have seen NTSC system, PAL system, and SECAM system in detail. We have also gone through the difference between NTSS system, SECM system, and PAL system in detail regarding different components. We have covered different television standards, what is composite video signal, then we have seen mixing of color perception, we have seen chromaticity diagram and different terms related to the color television transmission, how this color television transmission occurs, that related to that all the terms we have seen till now. Now we will see color TV transmission. Actually means whatever the process is done in that color TV transmission, different modulation processes, we will go in detail with that. In the actual process in color TV transmission we will see, or only the in the transmission of any television signal we will see what happens in that. Whatever the light reflected from an object is converted into the video signal, and that video signal is scanned video signal, that is left to right or top to bottom. Using different scanning principle, that video signal we scan in different manner. We use the two different techniques for the scanning, that is interlace scanning and progressive scanning. In the interlace scanning, that scanning reduces the bandwidth requirement to the half compared to the progressive scanning, whereas the progressive scanning gives us a high quality of video compared to the interlace scanning at the cost of bandwidth. Means, as we have seen before, that whatever the progressive scanning, which gives a high definition television signals as compared to the interlace scanning. The progressive scanning is more normally used in digital TVs, HD TVs, and computer, whatever the personal computer we use in our day-to-day life, because in that everyone nowadays everyone prefers a HD TV or HD signal prefer to watch. That's why progressive scanning is very much used nowadays. Synchronization, then the synchronization happens between the transmitter and receivers by using adding the synchronization pulses in the video signals. Then audio information is converted into the electrical signal by suitable microphone. Okay, we know the whatever microphone you might have seen in the mobile phone, whatever the video signal that is stored in by using the video camera, and whatever the voice in that particular video signal, that is stored by using the microphone. Video signal and audio signal is modulated, and both the signals are then combined and fed at the transmitter antenna. This is what happens at the any television transmission system. And at the receiver system, whatever the signal is received through the antenna, that is given to the picture and sound circuit, where picture and sound information is being separated. Now this video signal is separated and given to video processing stage. An electrical signal is converted into the picture information by using the picture tube, so that we can see it on the television screen. Sound signal is given to the sound processing stage, and sound information is then produced by loudspeaker. This is what happens in the transmission and reception of any television system. Now we will see the design principles of TV transmissions. In the television transmission, the video signal uses the AM, that is amplitude modulation. In the process of transmitter, you might have seen the modulation block. In the modulation, whatever now here in the television, consider there are two signals, one is video signal and one is audio signal. Both the signals we have to modulate before the transmitting to the channel or to the receiver. Then that whatever the video signal we have to transmit from transmitter, that video signal is amplitude modulated. In that we use VSB, that is vestigial sideband modulation, and in the audio signal we use FM, that is frequency modulation, for the purpose of transmitting that signal from transmitter to the channel. There are two types of AM VSB. Now whatever the video signal we are having, we are modulating that video signal. There are two types for modulating that video signal. One is high level modulation and another is low level modulation. Now we will see in detail about high level modulation and low level modulation. Let us see high level modulation. Here in the high level modulation, the carrier generated by the stabilized crystal oscillator is first amplified to the adequate power level using CRF amplifier. Means we use two signal for the purpose of modulation. One is original signal or baseband signal, whatever signal we want to transmit from one place, and another is carrier signal. These two signal are very important for the purpose of modulation. Whatever the carrier signal we are using here for the purpose of modulation, that is first generated by using a crystal oscillator, and that is amplified to the adequate power level so that it can be modulated with the original signal. The modulating signal is also amplified to a high power level before modulation takes place. We have to increase the power of both the signals, modulating signal and that particular carrier signal. The modulation takes place in the last class C RF amplifier. This is nothing but the block diagram of a high level modulation transmitter. The block diagram consists of amplifier or synchronization generator. Then we are having equalizer, phase compensator, VF amplifier, modulating amplifier, crystal oscillator, multiplexer, amplifier, PA driver, video output amplifier, VSBF and duplexer, then preamplifier, FM modulator, multiplexer, amplifiers, PA driver. We are having all these blocks. We will see it in detail now. By using the equalizer circuit and VF amplifier circuit, whatever the original or modulating signal, we increase the power of that particular signal before the modulation, and crystal oscillator generates the carrier frequency. That particular carrier frequency is also then the power of that particular carrier frequency is also increased by using amplifier and video output amplifier. Both the signal are then given to the duplexer. Then this VSBF and duplexer, that is filter, that gives us the that whatever the modulation, as we have seen before, modulation process occurs in that particular filter. Whatever the modulated signal is then given to the antenna for the purpose of transmission over a channel. This is nothing but the high level modulation TV transmission. Means whatever the modulation is done, we are increasing the power of both the signals that we are using for modulation, and after that by using the filter we are modulating at the process of filter or at the block of filter, whatever the modulation process is done there, and that after that process of modulation, that particular signal is transmitted over a channel. That is nothing but the high frequency level modulation TV transmitter. There are some of the disadvantages of the high level modulation. We will see the video modulator has to supply the high video voltages up to hundreds of volt into the highly capacitive loads. This takes the amperes of current at video frequencies. So vacuum tube amplifiers are required instead of semiconductor amplifiers. Means we cannot use that particular semiconductor amplifiers. We have to use the vacuum tube amplifier because we have to modulate that particular video signal to different video stages. Means we have to amplify, or we have to increase the power, so we have to give so much high capacitive loads, so we use the vacuum tube amplifiers. After that, filters are high power capacity is required for VSB filtering, okay, because we increase the power of the signal, so that whatever the filter we are using for the purpose of modulation, we have to use that filters with high power capacities. Due to high power modulation problems and use of vacuum tube amplifier requires more space. Okay, we have to use vacuum tube amplifiers, so more space is required and bulkless increases, and hence nowadays it is very rarely used, because nowadays you can see the TVs are very flat TVs. They does not consist of so much, they does not take so much space. That's why this high level modulation television or transmitter are not used nowadays. Now let us see low level modulation. This is also a type of AM VSB, that vestigial sideband amplitude modulation. In the low level modulation, this modulation takes place at low voltage levels of modulating and carrier signal. As we have, it is exactly opposite to high level. In the high level, we increase the power of the signal to very high level. In this low level modulation, we increase it to the intermediate frequency, we increase it to the intermediate level or low level particular power of the signal. The vestigial sideband filter is located after the modulators, hence VSB filter operates at low power level. Okay, because in the previous we are using that particular filters in the modulation, in the process of modulation, in the modulation we are using that filter. That's why there was a need of very high power. Here we are using that filters after the modulation, that's why there is no need of the high power. Low level modulation is also IF modulations. As I told before, IF is nothing but intermediate frequency modulation. You can call it as low level modulation or intermediate frequency modulation. Video IF frequency is 38.9 megahertz, so video signal modulation takes place at 38.9 megahertz frequency. Now this is the basic block diagram of that intermediate or low modulation transmitter. You can see there is a video processing unit which takes the video signal, and audio processing unit which takes the audio signal. Video modulator is used after that. Crystal oscillator, that is crystal oscillator, is used here for the purpose of generating the carrier signal. That carrier signal is given as input to the video modulator, and another input is given as a whatever the modulating signal from the video processing unit. After that we are using delay equalizer, VSB filter. You can see here VSB filter is used after the modulation. In the high level modulation it was used in the process of modulation. Here we are using it after the modulation. Video up converter is also used here. Linear amplifiers are also used. Duplexer is also used. For the purpose of processing the audio signal, we are using audio processing unit. After that we are using modulated oscillators. For the purpose of modulating that audio signal we are using it. Low pass filter we are using. After that audio up converter also being used here for converting the level of that audio signal. And after combining both the signal, that is audio and video signal, by doing the high level or low level or intermediate frequency modulation, this particular signal is sent over the transmission channel. This is nothing but the intermediate or low frequency modulated TV transmitters. There are some of the advantages of this low frequency or intermediate frequency modulated TV transmitter. At low power level, the semiconductor amplifiers can be used instead of vacuum tube amplifier. As we have seen before, in the high level modulation, there is need of vacuum tube amplifier because we have to amplify or increase the power of the signal to a high level. But here we do not need to increase its power to a high level. That's why no need of vacuum tube amplifiers, so that the space needed for that is reduced. Bulkiness is also reduced. VSB filters can be used at low power level just after the IF modulator, as we are not increasing the power and we are using that filters after the modulation circuit, so that they can be used after the modulator. Group delay equalization becomes simple at 38.9 MHz frequency compared to the channel picture carrier frequency. Then the visual exciters for all the channels in the TV bands are identical, so economy is also achieved. Thus, IF modulated transmitters has many advantages, including simplicity of design because no vacuum tube use. It is very simple in design. Ease of operation, no need to increase the power, so no need to give the more voltage and more current. And superior performance, it also gives a superior performance at a very low level of frequency. Also, video and audio processing modulating stages remains unchanged for all the bands. Here in the visual exciter system, which consists of video processing unit, a visual modulator, then VSB filter and phase compensator. All these, the 4 or 5 block together, we can call it as a visual exciter system. Or delay equalizer is also used in that, and frequency converter is also used. This is called as a visual exciter system. In the video processing unit, video signal of 1 VPP is processed in stabilizer amplifier to minimize the effect of hum, noise and other distortions. For video signal modulation, the different modulators we can use diode bridge modulator and diode balanced modulator also. If we use the diode balanced modulator, The diode balance modulators, in that solid state devices are used, that is vacuum tubes are not used here. So we use solid state devices, whatever the amplifier we need for the purpose of amplifying the signal to a low level. Hence there is no need, no tuning adjustments are required, and it provides the excellent linearity. So in that particular diode balance modulator, amplitude is modulated of the signal, and harmonics are also removed by using the filter. In the diode valence modulator, we can also AM modulated signal along with the harmonics are also present. Harmonics are then eliminated by using the filters. The phase compensator or delay equalizers is built in with the VSB filter to compensate the phase distortions here. The VSB filter is also designed with the lumped components consisting of four sections of low pass ladder network attenuation frequencies beyond 1.25 MHz above the carrier by more than 20 dB. Frequency multiplier, or we can call it as a frequency up conversion, is also basically a mixing process where the carrier frequency is added with the 38.9 MHz. That gives us a channel picture carrier frequency, so that that particular frequency up conversion or frequency multiplexer is used here. The frequency up converter can also use the diode bridge modulator that we have seen just now. Thus the linear amplifier and power amplifier are used to amplify the modulated video signals power. Getting the concept? Whatever the this particular visual exciter system, this visual exciter system consists of video processing system, okay, then visual modulator, then VSB filter, phase compensator, or we can call it as a delay equalizers, and frequency converter. All these blocks consist, we can call it as a visual exciter system we have seen just now. Now we will see audio processing unit or audio exciter system. This particular audio exciter system that consists of audio signal here, the audio signal that we are taking by using the microphone, the audio signal is pre-emphasized to reduce the noise in high frequency audio range. Here, that particular FM direct modulation is done with the varactor diode modulation and LC oscillator. These two types we can use here. Thus, the carrier frequency used here is 33.4 megahertz. Here, the frequency up conversion is basically a mixing process. Whatever we do up for the up conversion of the frequency is nothing but the mixing process, where the carrier frequency is added with the 33.4 megahertz, which gives us a channel sound carrier frequency. As we have seen in the video exciter system, we are using 38.9 megahertz frequency to add with that particular frequency. Here we are adding the carrier frequency with 33.4 megahertz, so that we can get a channel sound carrier frequency. Thus the linear amplifier and power amplifier are used to amplify the modulated audio signal power. Whatever the modulated signal, we do not increase the power of that particular signal before the modulation, we increase it the after the modulation. Thus VSB modulated signal and FM modulated audio signals are combined in the duplexer that particular duplexer unit, and it is given to the antenna, so that we are having total signal. One is video signal and one is audio signal, that is combined in the duplexer, and it is given at the antenna for the purpose of transmission. Now let us see what is the duplexer. The duplexer unit that is used in IF modulated TV transmitter, CIN duplexer, or we can call it as constant impedance notch, that combines the visual and oral, means audio, visual and video and audio power to feed a common antenna feeder while maintaining the sufficient isolation between video and audio signals. Any audio signal that leaks the past the cavities, or any visual signal that is reflected at DC2 due to the imperfection of matching and short circuits, it goes into the port 3 and DC1, where dummy load absorbs the power. That this particular happens in the duplexer unit. That particular duplexer consists of one copper DC1 unit, then audio notch cavity, that is second cavity, 3 dB coupler, that is DC2, and audio notch cavity ANC1. Means in this particular duplexer, the isolation between visual and video and audio signal or input ports is maintained, while the two signals that we combine at the output port, okay, whatever the output of the port of that duplexer, we combine that signal, and there and after the combination we provide or feed it to the antenna for the purpose of transmission. This is what happens in the multiplexer, where we add the audio and video to signal, that is output of that particular visual exciter system and output of the audio exciter system. This is all about the low modulated TV transmitter or intermediate frequency modulated TV transmitter. Getting both the terms, high modulated TV transmitter and low modulated TV transmitters. Now let us see the difference between the low level and high level modulation system. Here in the low level modulation we will see with comparison with the different parameters. First parameter is point at which the modulation takes place. In the low level modulation, the modulation that takes place in the initial stages of amplification, but in the high level modulation, that modulation takes place in the final stage of amplification. Means in the low level, initially we modulate the signal and then amplify the signal, but in the high level modulation we amplify the signal, we increase the power of the signal and then we modulate that particular signal. The power levels in the low level modulation circuitry has to handle low powers. In the high level it has to handle the high powers, because we increase the powers of the particular signal before transmitting it to the channel. The complexity, the modulation circuitry is simple as it has to handle the low power in the low modulation, but it is complex in the high level modulation because we have to increase the power. So we use a vacuum tube amplifiers and bulkiness increases of that particular circuit, and it is a bit complex circuit than the low level modulation circuit. The prime factor in design we will see in the low level modulation. Here simplicity is the prime factor, that is requirement. Prime requirement is high efficiency and low distortion in high level modulation. The amplifiers we are using in the low level modulation are linear amplifiers, such as class amplifier is used here, class A amplifier, sorry. In the high level modulation, class C amplifiers we are using for the purpose of amplifying the power of that particular signal. Efficiency is very low in low level modulation, while efficiency is very high in high level modulation. Getting the difference between the two, now we will see the next point, that is nothing but the typical television receiver. This is a block diagram of a television receiver. Till now we have seen the transmitter, receiver, everything. We will go in detail with the television receiver. Whatever the process occurs in the television receiver, it occurs for the two signals, one for video signal and one for audio signal. Initially whatever the antenna receives is nothing but a mixed signal, that is video signal and audio signal. By using different blocks, that particular video and audio signal is differentiated. After that, video signal is amplified, or different processes are done in the video signal, and the same processes are done in the audio signal, and it is given as a at the television receiver. Now let us see in detail. The first point in this television receiver we will see is antenna. The main function of the antenna is to accept the electromagnetic waves that are coming from the television transmitter. The antenna receives these waves and converts them into the RF signal. Whatever the waves that are transmitted by the transmitter, that is received by the antenna, and that are then converted into the RF signal, which RF signal is given to the TV transmitter. For better reception of the RF signal, Yagi-Uda antenna is most commonly used in all the television receivers. There are different types of antennas. One of the antenna that is mostly used is Yagi-Uda antenna. Now let us see the next block, that is RF tuner. You can see in the block RF tuner. That RF tuner is used for the better picture and sound reception of a signal. The main function of the tuner is for the selection of desired channel frequencies, and that rejects the other. Whatever the frequency is needed, only that particular frequency is selected. As name indicates, tuner, you might be knowing the tuning process. In the tuning process, whatever the frequency is the important, or whatever the frequency is of interested, that frequency only we tune. In that way, only the desired channel frequency is tuned and other frequencies rejected in this. It matches antenna with the TV receivers because of the ghost images can be removed, because whenever we match the antenna with the TV receiver, whatever the extra noise or ghost image that are removed, it converts the RF signal into the IF signal by heterodyne with local oscillator frequency. This RF tuner isolates the local oscillator signal from the antenna for preventing radiation of it through the antenna. This particular RF tuner rejects the image frequency which causes the ghost image, means whatever the frequency is needed, only that particular frequency is selected, and remaining all other frequencies which causes noise, which causes the ghost images, that are removed by using or rejected by using this tuner circuit. The RF tuner that select the RF signal of the desired channel amplifier and then to the IF signal. The tuner consists of RF amplifier, an oscillator and a mixer stage. All these three blocks are present in the RF tuner, that is RF amplifier, oscillator and then mixer stage. You can see in the diagram, after the antenna there is RF amplifier, then there is a mixer, and then there is a oscillator, local oscillator. All these three stages are present in this particular RF tuner stage. The desired channel that amplifiers, then it is to IF signal. The tuner consists of RF amplifier and oscillator stage. The local oscillator generates and constant frequency for desired channel. RF amplifier amplifies the RF signal that is achieved from the antenna, and then mixer stage converts them into the IF signal by heterodyne RF signal from the local oscillator frequency. Here the IF carrier frequency that present in the IF signal for picture and sound, then that are 38.9 MHz and 4 MHz respectively. Thus IF signal is achieved from the tuner and that is fed to the IF amplifier stage. Here preamplifier, that is IF preamplifier is used, that amplifies the IF signal. This stage of amplification is necessary because by the use of SAW filter, the gain of the receiver becomes less. That's why we use the preamplification for the IF signal. After that we are having SAW filter. The SAW filter is used in place of wave trap circuits. Whatever the wave trap circuit, in place of that we are using the SAW filter here. It passes only required frequency and grounds unwanted adjacent channel frequency. That's why filter is for the purpose of filtering different frequencies and using only the desired frequency. The video IF stage, here we are having the video IF stage. Here both the signal as video signal and audio signal are differentiated. In the video IF stage, by using an IC, this stage is desired. This stage consists of video amplifier, AFC and AJC circuit, as you can see. One is video amplifier, keyed AGC and video detector. These three circuits are used here. Video IF amplifier, in the video IF amplifier, that amplifies the IF signal, okay, and provides sufficient gain. AJC voltage is applied to all the separate IF amplifiers except the last IF amplifier. From video amplifier, whatever the signal is applied to the video detector. In the video detector process, which is the next part to that IF amplifier, video detector, signal obtained from the video IF amplifier that is injected to the video detector, that is given as input to the video detector circuit. In video detector, the signal is demodulated. In the process of transmission, we have modulated the signal, and now we have to demodulate the signal, because we have to get whatever the information was transmitted, original information to be transmitted, so that the opposite process of modulation, that is demodulation, is to be performed at the receiver side. That demodulation is performed by using video detector, and that demodulation gives back the Y signal and the color sideband along with the various synchronization pulses, because whatever the Y signal was at input and color signal, different color signal for that particular were present at the input, that all the signal we get after the demodulation process. AFC signal is then also given to the tuner section for automatic frequency control. The video detector is to mix both VIF, SIF for the process of producing a new IF sound and IF signal that is at 5.5 megahertz and then fed to the sound section. Now we will see whatever the process is done in the sound section. Now whatever process we have seen, that is done in the video section. We have we are using IF preamplifier, SAW filter, and in the video detector we have seen video detector, video IF amplifier for the purpose of detecting the video signal and separating audio signal. Then this whatever separated audio signal is given to the sound section. So that sound section consists of sound IF amplifier. In the sound IF amplifier, the 5.5 megahertz intercarrier signal from video detector stage that is fed to the sound IF amplifier for the purpose of amplification. In the FM detector, 5.5 megahertz sound signal is then amplified by the SIF stage that is given to the detector stage, that is FM detector. You can see in the diagram. The original sound signal is detected from the carrier frequency. In the audio amplifier, in that stage, the voltage amplification is given to the audio signal and finally that is fed to the speaker so that we can get whatever the audio that is synchronized with the video signal. Now we have seen the video amplifier for the process of video signal after the detection. Whatever the output of that particular video amplifier, that is video signal, that is given to the video preamplifier. This signal consists of whatever the signal at the input of video preamplifier, that consists of luminance, that is Y signal, the color subcarrier signals, that is containing red, blue color different signals, R minus Y, B minus R, all these color different signal. The horizontal and vertical synchronization pulses are also present there, and the color burst signal is also present there. Here what happens, the video preamplifier amplifies all the signal strength from 2 volt to 6 volt so that it is able to drive video output stages. In this stage, the division of chrominance and luminance takes place. From the video preamplifier, whatever the video signal is coupled to the chroma and bandpass amplifiers through the chroma filter circuit and synchronization, separation and delay time circuit. In the delay time circuit, whatever the process is done, we will see now. In the delay time, whatever the from the video preamplifier, Y signal that passes through a delay time to amplifier stage. First delay is given to the Y signal and then it goes to the amplification stage. The delay line delays the Y signal by 0.8 microseconds. 0.8 microsecond delay is given here. The delay speed of the signal through the delay time is spatial coil which very high value of inductance and so the distributed capacitance, so that the delay speed of the signal through the delay line is greatly reduced. That's why we are using the delay time. After that, we are having a chroma section. In the chroma section, the output of the video preamplifier, the composite color signal that is coupled to the chroma bandpass filter at 4.43 megahertz, and the two stages of the chroma amplifier, the chroma filter that separates the modulated chroma subcarrier signal and the color burst signal that is incoming composite video signal. Both the signal we get separated in the chroma filters. The separated chroma signals are then amplified by first chroma amplifier, which is gain controlled by the voltage developed by the automatic color and control amplifier. This is how we get the separated chroma signal and separated chroma amplified signal. Now in the color burst circuit, the color burst circuit consists of burst preamplifier, preamplifiers, pulses, shapes and gated burst amplifiers. Here AFC circuit is also used, that is automatic frequency control circuit. In this stage of AFC particular circuit, the horizontal flyback pulses and horizontal synchronization signals are separated here. In the horizontal oscillator, that generates the 50,625 Hz sawtooth horizontal line frequency for the horizontal deflection of electronic beam inside the picture tube. In the horizontal driver, the signal is coming from the horizontal amplifier is amplified, simply amplified. In the horizontal driver transformer, that particular provides the impedance matching stage. In the power supply unit, a SMPS power supply is used to get a 1153312 volt DC power. This much high voltage is needed, DC power is needed for the purpose of that particular television receiver. So we are using a SMPS power supply unit. This is nothing but the total block diagram and its description of the television receiver, basic television receiver. It can be either color television receiver or monochrome television receiver, whatever the signal you get at that the signal. Okay, here the topic ends, that is fundamental of color television. We have seen everything related to this fundamental of color television. Thank you.